This video is on how to determine the percent mass of water in a hydrate using experimental data like the lab that most kids have to do in honors chemistry, in which they do this for copper sulfate pentahydrate. Now, all hydrates consist of two parts or components. They consist of a salt, and the salt is basically an ionic compound. This is not important right now, but I'll talk about it more later. They're an ionic compound, which means they're made of ions, usually a metal and a non-metal. Okay, and then they have a certain number of molecules of water for every single piece of that ionic compound, right? So the ratio that you're going to find here is always going to be 1 of the salt to X amount of water. And X can be equal to anything. If X is equal to 1, then it's a monohydrate, right? If X is equal to 2, then it's a dihydrate. Right? And they have all sorts of other prefixes like, pentas 5, hexas 6, just like in geometry. And essentially, we use these compounds in lab because they give you a way of doing gravimetric analysis in which you're very likely, as long as you don't overheat the compound, to get the right mass ratio and therefore the right ratio of moles and getting the formula of the compound. So the general way you do this is you put the compound, which is hydrate, inside a vessel, often a crucible, which can stand the heat of a Bunsen burner, and you place a mass. When you put the mass in there initially, this mass will contain both the SnCl2 and it will also contain the water together. And as you add heat, right, what will happen is you'll be left with a crucible, and the mass here will actually decrease because off will go the H2O. And what seems to confuse students is what is in the data table. So here's what you'll get. You'll give you an empty crucible, and they'll give you the mass of that. Let's say it's 3.00 grams, right? And then they're going to add the crucible, and the crucible will be, come before, heating. So before you actually heat it. And let's say that weighs 15.50 grams. Now, the understanding is that is got the tin chloride here, and the water. Sn, by the way, is a symbol for tin, right? And then they'll give you, the crucible after heating, and that will weigh less because it will have lost water. So as soon as you look at this, you're supposed to recognize that if I find the difference between these two numbers, between 15.5 grams and 13.50 grams, I know the mass of the water. So I know in this particular case, I have exactly 2.00 grams of H2O because 15.5 minus 13.5 is 2. Or the difference between $15.50 and $13.50 is $2. This is not tough math, right? Okay, now, what is the mass of the other part? So we know what the mass of this is. We just need to know what the mass of that is. Well, the good thing is, after heating it, we know what the crucible weighed, right? And this is the crucible with the stuff in it where the water is gone. So if we subtract from this the 3 grams, we have the mass of what's left in here, which is just the SnCl2. So we know we have 3 times 13.50, we have 10.50 grams of SnCl2. I'm going to pause this for a second so I can do some math here. Now, at this point, what I've done here is I've just simply divided and converted each thing into moles. So I want to figure out how many moles of water I have and how many moles of SnCl2. 18.02 grams is the gram formula mass of water. I did that work for you. And 189.6 is the gram formula mass of SnCl2. And so when I divide the 2 by 18.02, I get 0.1109 moles of water to 0.0553 moles of SnCl2. And so I do the same thing I normally do. I divide by the smallest number. Now, note something. This will always be either the exact same number or the smaller number, because in the end we always get a ratio of 1 to 1 or 1 to 2 or 1 to 3 or 1 to 4. So this has to be the smaller number of moles, or it could be the same if it's a monohydrate, right? So I go 0.0553 over here, 0.0553, and this basically gives me, for every 1 mole of SnCl2, this comes out to 2. I get 2 moles of H2O. And that's the formula of our hydrate. The other question they can often ask you once you've gotten this far is they can also ask you to determine what percentage of the mass was one part or the other. Now, how do we do that? Well, we have to get the mass whole. The one number we haven't gotten here, right, was the mass of this right here. But we know what the mass of this stuff in here was originally because we know what the crucible weighed before we added it and what it weighed afterwards, right? So if we subtract the mass of the crucible, we have the weight before heating. That weight before heating is the salt with the water. So we know experimentally, right, that we had 12.5 grams, okay, of the SnCl2.2H2O. And if we want the percent mass of the water or the other thing, we can take either one of these components and figure out the percent of one part or the other. So imagine I want to know the percent that's water. Well, I can put the 2.00 grams on the top, and I can just go 2 divided by 12.5. And then, of course, since I want a percent, I'm going to multiply it by 100 because I want a fraction out of 100. And that gives me 16%. Now, you could go back and figure out the mass of the other part, but you don't have to because it's only 2 parts of a whole. And if one part of the whole is 16%, you know, since it's 60% water by mass, you know the other part has to be 100 minus 16. And 100 minus 16, I'm pausing for you to think of it, is 84%. So 84% by mass SnCl2. So you have 2 types of problems. One, okay, you can determine the empirical formula. Just make sure you understand what you have in your data. You have an empty crucible. You have the crucible with the salt and the water. You have the crucible that's now missing the water. So you need to know how to use those numbers to figure out what you have. So you have to make sure the numbers correspond to ideas. All right, that's how you do hydrates.